Okay, so first off, I'll say a little bit about the final exam. I'm sure that's something you're wondering about. So the final exam will consist of questions that are multiple choice, true or false, and short answer. Okay. You can bring one piece of paper with you, just a normal 8.5 by 11 piece of paper. You can write whatever you want on it. So I'm not going to test you on any memorization. Okay, whatever you might want to memorize, you can just write it on your piece of paper, and then you don't have to memorize it anymore. Instead, the questions will be conceptual. So I might give you a new scenario and ask you to apply the concepts from class. Or I might say, here's a concept from the start of the course, like SSL, and here's a concept about cookies and like how do they relate to each other, that type of thing. So the goal is, is to really measure how much you understood the material. In terms of studying, it's just important to really understand it. So just go back over the lectures. Maybe you can start with the PDF, and if there's concepts that you don't remember or you don't really get, then you could re-listen to the lecture itself. And the concepts that you're good on, then that's fine as well. Okay, so just spend your time just making sure that you understand what's going on in all of the examples that we gave and things like that, and you should do well. The exam is, I don't know, if students do find the exams hard, and the marks aren't always super high, but anyway, the students that really understand the material, it's the kind of exam where they leave after 30 minutes, right? They go in and they're out. And then if you're not so sure about the concepts, then students will sit there, for a long time and might sit there for 3 hours, like trying to think about things or whatever. I'm not sure what's going through students' heads, but anyways, so that's sort of the nature of the exam. So you will have, I'll give you like the full exam period. I forget what it's scheduled for, but hopefully you only require 2 of the 3 hours. I think it's for 3 hours, but if you want to sit till the end, you can sit till the end. Bring a pencil, not a pen. You can write your whole exam in a pencil. I advise it because it's easy to erase it. And sometimes students think that they are not allowed to use a pencil or something. I don't know why. But anyways, I encourage a pencil. But you'll need a pencil for the Scantron form. So your multiple choice, at least my plan is, maybe I'll change it, but my plan right now is to have you fill out the multiple choice on a form that can get scanned. And they want a pencil. And also, if you do in pen, you can't change your answer if you decide you want to change it. So bring pencils. I'll have some extra ones if you forget. And then just normal exam rules. So like no phones in your bags like away from you, sit every other seat. It will be in the FG building, I believe, in the basement. If you've never been down there, it'll be fun for you. And yeah, I don't know, I'll mention this all again at the start of the exam, the sort of logistics of it. But yeah, any questions about it? Yeah, so you can bring one piece of paper, you can write whatever you want on it, you can write small, you can bring a magnifying glass, I don't care. And I would let you bring your book or whatever. The problem is that then students are like, you have a bunch of stuff on your desk and people are ruffling around and it's just distracting. And so that's why I just keep it to one sheet of paper. But my goal is that you'll learn a lot about the course preparing that piece of paper, and then you'll never have to look at it during the exam. We'll see about that.
Sorry, will you show us one example from multiple choice and one example from short answer?
I don't have one prepared. I don't want to.
Just an example, can you say something?
Okay, so one example for sure. This is the easiest question, so it's not very much to go on. But you can expect some stride question that's like, okay, this happens. Is it spoofing? Is it tampering? Is it information disclosure? So that's one question that is always on the exam. And then it might ask you about like, I don't know, this is a scenario that happened. Here's 4 attacks that we talked about in course. Which one's the most likely to have caused this scenario?
Short answer.
That would be like a multiple choice. Short answer could be like just explain something, like I don't know, explain how Tor works. That's kind of vague. That's too high level, but something like that.
But it's not short answer. How to works.
Yeah, so short answer I would aim like usually they might be worth like 4 marks. Like a multiple choice, sometimes I do true false, so they might be worth a half mark, and then a multiple choice might be worth 2 marks, and then a short answer might be worth something like 4 marks. And if it's worth 4 marks, I'm looking kind of for 4 things. Like there's sort of a mapping between the marks and what I'm looking for from you. And then it might be like a couple part question. Like, so there's kind of a scenario and it asks you about one thing and then another thing. And each little part is worth a couple, like 4 marks or something.
Usually, how many short answers you ask?
Usually it's like, I don't know, maybe 2 pages a short answer and then 30 to 50 multiple choice. Or that could include true, false too. I don't remember the numbers off the top of my head, but it's somewhere around maybe 30 multiple choice and 2 short answer. That's roughly correct. It won't be much off from that.
There's no negative marking there.
And there's no negative marking, yeah. I did it before, but students hated it. And it doesn't matter in the end of the day because like you want to, like your relative mark relative to the rest of the class is more important than anything else, let's say. The actual absolute mark doesn't really matter much because we bell marks up. And I've never belled down. I mean, it's a potential possibility, but in the past I've always belled marks up. Any other questions? Okay, but anyway, the main insight is just don't stress yourself out memorizing things. Just try and understand it. Just go through and be like, okay, did I really understand that concept? And and then make a list of like the concepts that you understood worst to best, and then just start at the top and get through as much of the list as you can by just rewatching the lectures and going over the concepts. Okay, other questions? Okay, so good luck with it and all of your exams. I know it's a busy time and you have projects and stuff due. Okay, this class, there's actually a fair bit of material I want to get through. I just want to make sure that we finish it in time. And so I pre-populated the notes. So it'll be more like slides where everything is already there. Mostly, I'll draw out a few things. But I'll try and go slow because I know some of you will be keeping your own copy of the notes. Okay, so this class, was there any questions from last class, by the way? Okay. So last class we talked about the cookie policy. So just in short, the pros of using cookies are they keep you logged in. That's the main reason why. Or they remember something about you. So it doesn't have to be a login. It could be like that you prefer the English version of a website. But anyway, so personalization of website features, it remembers it, it's sticky. As long as you keep going back with the same browser, it's going to remember you. And then if you log in, it can remember your session. And so when you come back, you don't have to log in. Or every time you click on an email, you don't have to log in, that type of thing. Today, we'll talk about something called cross-site requests. So this is also a feature that uses cookies, basically. It wouldn't work if you didn't have cookies. They're either good or bad. Generally, they're good. There is an attack called cross-site request forgery that's bad that we'll also talk about. But generally, it's considered a feature as opposed to a bug. The cons or the negatives of cookies are, for privacy purposes, websites can follow you around. So we gave an example where you go to one website, you're looking at a product, and then you go to another, and that website somehow knows what product you were just looking at and shows you an ad. And that's because there's some third party that's behind both of those websites. They have to be in common. That third party is often someone like Google or Facebook, or it could be an actual ad. There's a bunch of ad companies that you maybe haven't heard of as well, like DoubleClick and that type of thing. And so those are the websites that are maintaining that. The other sort of drawback of cookies is if I steal your cookie, I can be you. So we call that session hijacking. And it's not quite as bad as stealing your password. It's very, very close. If I steal your password, I can impersonate you forever. I can even change your password so you can't get your password back, right? If I steal your session cookie, right, I can impersonate you until that cookie expires. So there is a shelf life to how long I can do it. And I may not be able to do things. So it's been more common in recent times that, like, for example, you cannot change a password with just a cookie. So if I'm logged in with a cookie and I can change all sorts of settings. I can read all the account details. But if I change the password, it will say, okay, you need to type your old password before you type in your new password. Okay, so some administrative tasks you need to re-authenticate in order to do them. It's not enough to just have a cookie. Okay, and that's because it's slightly easier to steal cookies than it is to steal passwords. Okay, questions about this? Okay, so let's we'll pick up on cross-site requests. So this is something else that's both used and abused. So imagine a scenario that looks kind of like this. You're on some news website and Facebook has plopped something at the bottom of the article. And it has like a like button so you can like it. And if you click that, it will like it on Facebook. Okay, if you then go log into Facebook, people can see that you liked that article. And it might even see, I haven't used Facebook in years, but this is how it used to work. It might say something like 2 of your friends like this article. Okay, now my question to you is, how did the news website, how do they know how many friends of yours like the article? Okay, so I could log in into Facebook when I'm on this website. I'll tell you, though, that this will happen as long as I'm logged into Facebook, period. So if I'm logged into Facebook and I just load this website, I could see this particular thing without explicitly logging in on this particular website. Okay, let me ask a slightly easier question maybe. Does the news website know all my Facebook friends? Okay, so people think no. How's that possible? I mean, I'm looking at their website and it's saying that 2 of my friends like the article. And I'm telling you that that's true. Okay, it's not like they just made it up. That's true information. So how is the article showing me this information if they don't know it? Okay. So is it possible that Facebook fills in this box without the news organization knowing what goes in the box? Okay, so the answer is yes. So there's a concept in web, like HTML, called an iframe. Okay, and so usually the way you would set this up is with an iframe. So basically what will happen is you'll start by requesting the high-level page, right? So you'll go to the news organization. It will have a server. And you'll request, whatever, index.html, and the news organization will send you back this page. And what it will have in the response is it will have a blank space here, basically, okay, like a frame that's a certain size. It would look something like in HTML, just like iframe. And then whatever, facebook.com. It would usually be a long URL with a bunch of parameterizations that we'll talk about later. Okay, and what this tells, and there would be a size and whatever, this is just simplification, okay? But what this tells the website is go make this box, this iframe, and then wander over to facebook.com or whatever URL is put here, and they're going to fill in that box itself, okay? So I'll download it. I'll have this blank space. This iframe is contained in the HTML of the actual response itself, okay? And in order to fill what's inside this frame, then I would open a connection to facebook.com. I would make a request for whatever URL is sitting here. and then Facebook will send a response that will get filled in by the browser into this square, okay? So the website never sees it, okay? The website just says, here's a box, go ask Facebook to fill it in. The browser, of course, which is showing you the website, it sees everything, okay? So the browser sees it, but the website itself doesn't actually see the information, okay? Now next, when we make a request to Facebook, do we include a cookie or not? Yeah, okay, so let's say we're logged into Facebook already, then yeah, all our cookies are going with every request to Facebook, okay, including frames. There's no special rule about frames. So in this request, any cookies we have for Facebook, for example, a session ID, will get sent along with this request. Then Facebook can say, okay, I know, I've seen this session ID before, and it belongs to whoever, Alice. And so then I'll consider A logged in. Then I can go look up A's account, and it's up to the website itself. So when they create this iframe, they'll often pass information into it. So if this iframe literally just went to facebook.com, then Facebook would say, okay, it's an iframe. I know what this is, but I don't know the exact content that the user was looking at, right? I don't know that they were reading this exact article. So it's up to the news organization to usually pass some information in, usually in the URL. So the news might put info in the URL, and I'll show you how they do that later. But anyways, they'll say this is the exact article the user was looking at, and then Facebook can go look up your account and see how many of your friends like it, and then they can fill that in, and that's basically how it works. So the response will be customized. Okay, so and then what the browser does as well is it enforces a rule that we'll fully specify in a bit, but just to give you a heads up, it's called the same origin policy. And it basically says, okay, this news website, the first site you came down, and the Facebook website that's in the same origin, in the iframe, they're from different origins. They're not from the same. One's from news.com and one's from facebook.com. So these are different origins. And therefore, we're going to basically separate them. And I'll talk about what that means exactly. But it basically means that what's running inside this box, let's say it's JavaScript, cannot read or write to the content outside the box, and vice versa. The content outside the box, which could be some JavaScript, it can rewrite itself, so it can control all the elements on this page, but it's not going to be able to change or read any of the things that are inside the box itself. Okay, so iframes are one way of mashing two websites together. They're not the only way. Okay, and so the same origin is going to apply differently. Sometimes you actually want that communication between them. So anyway, so that's where we're going eventually. Okay, is this clear? Any questions?
But at the end, the news website will understand who are our friends, just the friends who like that article.
Yeah, so it won't. All the news organization is it said, make this box, right? But then notice we never communicated again to the news organization. Like we never sent any other packets to it. So there's no possible way, I mean, this is a simplification obviously, but in this simple example, there's no possible way the news could learn what was put in this box, because that would at least require us to send it back to the news organization. But you notice that we were able to fill this website in completely just by talking once to the news server and then after talking once to Facebook server. Yeah. So your browser, the thing that's confusing is your browser puts all this information together for you, right? And so sometimes you think, well, whatever I'm seeing in the browser is what was sent to me by the website, but that's not true, right? Often what you see in the browser is a combination of different pieces that were sent to you from different websites, and those websites don't know the other parts, the other combinations of the page. Yeah. Okay, other questions? Okay. Now, this could be problematic. Okay, so this might strike you as being pretty powerful. For example, the news organization, even though they can't read what's in the box, they are still able to somehow, they're able to get my like Facebook information like pulled into their website. And so it seems like maybe they could do something with it malicious, or is the same origin so strong that you can never break through and you can never do anything malicious with it, okay? And so it took a while for people to sort of weaponize this particular feature, but eventually they realized that there is a way to attack cross-site requests, or to use cross-site requests, the functionality of it for an attack. But what had to happen first is that we kind of changed how the web worked in terms of how we communicate, how we send these requests and these responses. So let me give you an example, and then I'll show you the forgery. Okay, so actually this URL is fine as an example. Let me actually instead I'll go. If I go to Google, Safari's smart enough to rewrite the indicator here. So I'll use Bing because no one uses Bing. Okay, so here I am. I'm on a search engine, right? And so I'm going to type in CF Montreal and I'm going to press search. Okay, how does that search term CF Montreal, how does it go from my computer to Bing in this case? What HTML tool do you use to transport that across? Okay, so all those network protocols are used. So it goes over HTTPS or in this case HTTPS, which is over TLS, which is over TCP IP, and it uses DNS and all that stuff. So maybe the question's too vague to answer. So there's two answers basically. So if we roll back to the 1990s, we would use something called a post request. So a post request is just like a request here. A request is like GET. It's like a GET request. So it's like, get this information for me, okay? So there's two kinds of requests. There's a GET, which is just give me what's at this URL. And there's a POST, which is here's some data. I'm going to post it to this URL. And then the website can learn it, okay? So that's traditionally how you would push data from a user to a web server, okay? Now, in the web, it's easier for a bunch of reasons. The problem with post data is that you have to then remember and process the data when you receive it. So you're the web server, you get this post request, you have to store it somewhere, you have to remember, oh, this came from this user, and it just, it requires you to, as we say, generally keep state. So you have to remember the state of various things. And what were the last three things that this person asked for? Right? Well, I have to store them all. So I'm keeping all this state about each of my users. And so what the modern web has tried to do is it's tried to move to can the server know what you're asking for without remembering anything, without having to write anything down? And so the more common approach, which is called RESTful architecture, is we dump the search term in the URL, and then we just say you do a GET request for that URL. Okay? So you can see in this URL, it's bing.com search ? Q, which probably stands for query, equals CF Montreal. Okay, and then there's a bunch of other garbly goop that we'll come back to. But anyways, so what happened is when I typed CF Montreal here and press search, it didn't post that information. What it did is it created, using JavaScript, it created a URL with that search term in the URL, and then it just requested it. Okay. Now, let's say I go to, I don't know, page 5 here of the search results, right? Where I am in the search results will also be in this URL somewhere. I can't parse it out. I think it's probably first equals 4, which means it's on the 4th page. Okay, so it didn't remember that I asked for the 4th page. It just put it in the URL, and then when I asked for the URL, it's just like, okay, they want to know CF Montreal in the 4th page of results. Okay, now if I copied this URL and I sent it to you in an email, and you clicked on the URL, right? It's not going to say, oh, they didn't search for CF Montreal. I don't have a history of this person ever searching. It'll just say, okay, they want to see search term CF Montreal, page 4 of results, and it will take you directly there. Okay, so everything is contained in the URL, and all it does is it looks at the URL and sends you the information. It doesn't remember anything about where you were, or how you got to that URL, or anything like that. Okay, so that's an example of RESTful an API. And you can see Moodle works the same way. So there's a course ID. So I'm on this course website, and there's some ID here. Okay, it doesn't remember that I logged in. I went to the main screen, and then I clicked on, 6150FF or whatever. It doesn't remember that full history. It just created this URL, and this is the identifier for this. If I want to go to another course in Concordia, I can overwrite it. Probably won't work because I probably don't have permission. But this is how you find, this is how like attackers sometimes work, right? Is because stuff are in URLs, you can sometimes move between accounts just by changing like ID numbers. So you can see there's some course EdJuke 382, and this has this particular ID. Okay, so it doesn't know that, oh, I'm not enrolled in that course, right? Or I'm not clicking on that. It's not appearing in my link. It's just like, okay, they're asking about this course with this ID, so I'll show it to them. Okay, so if we combine that feature, the idea that we're going to pass in instructions to a website, like give me the search results for this search term in the URL, or the URL is enough. If I can just get you to go to that URL, it's as if you searched for CF Montreal and went next 4 times. Okay, it's just as good as you doing that. Then what I'm going to do is I'm going to make a URL like that. I'm going to dump it in an iframe, and you're going to go to the website. This iframe is going to load. You're going to send that request because it's coming from you, right? Just like you sent the request for facebook.com. You're going to send the request, and the news organization, they chose the URL that appears here, okay? So I can choose any URL. If I can lure you to my website, so I have to get you on my website somehow. I get you on my website, and then I have an iframe, right? And it has whatever URL I choose, your computer is going to hit that URL, okay? If you're logged in to the website that you're hitting, and I can make you take actions based on the URL by itself, then that website's going to say, okay, this person's logged in, and they're asking me to do whatever the URL tells me to do, so then I'll do it, right? So, for example, if you're logged into your bank, and I can say transfer amount from your account to my account, and I can put all that in a URL, I can get you to come to my website. I'll give you that URL in an iframe. Your browser will go load it. It will put your cookie in front of it. The bank just says, oh, this person, they're logged in, they have a valid cookie, and they're asking this money to move. Then the bank will move it. Okay? So this is called cross-site request forgery because we're forging cross-site requests. It was a big problem with the web for a long time. There was like a 5 to 7 year period where people were finding these vulnerabilities, and often they're subtle or they're kind of hidden in small parts of websites and things like that. So we went through this period. Now there's pretty standard ways of defeating it. I'll show you the most common one, which actually was already in that Bing URL, although I didn't point it out. There's a standard way to prevent this from occurring now. But anyways, it shows you that because of the way the policy was designed, that anyone can just pull in a URL and you're going to drop the cookie on it, right? That can be abused, okay? So the way it works is basically, I'll walk through the example that I just sort of said in words. So I have to, first off, I have to lure you into visiting my website. So I have some evil website, and I trick you into coming to my website. Okay, so that's fine. Then what I do is I put in an iframe, and the iframe will be to say bank.com. And because of the same origin policy, I can't, like, say I asked you to put your username password in here. It's not like I could read it out. Okay, when it's in an iframe, it's isolated. So it looks like the same origin policy is sort of saving us from any, like, it shouldn't be dangerous to go to an evil website that links to my bank or puts an iframe into my bank, because they can't talk to each other anyway, right? So who cares? What's dangerous about it? Okay, so what will happen is, let me just do it in red. So first off, this iframe doesn't even have to be visible. I can make it like 1 pixel by 1 pixel. So like you wouldn't even know that it was there. You wouldn't know that bank.com was hitting unless if you looked at the HTML, which no one does. And by the time you look at the HTML, it's too late anyway. It's already loaded. Okay. So what will happen first is I'll request the top level page. I'll get a response. The response itself in HTML will include the iframe. I can choose whatever I want here. So the attacker try and write a little neater. Okay, and then what will happen is I will go and I'll make a request. The user will make a request to the bank for this URL. Okay, so this is what they'll be requesting. Any cookies they have for the bank, so let's say that they're logged into the bank, will go along for the ride. And just like in the previous example, the bank can say, okay, I know who this SSID is. I know it's Alice. And so when I send my response, it's as if Alice requested it herself. So it's as if Alice is logged in. Okay. And the URL, what do I dump here? So this is just sort of fictitious, but anyways, you could imagine a URL like this. So bank.com/account ? Transfer to Eve, transfer amount 100 or whatever. Okay. So if the bank worked this way, right? If the bank accepted these instructions through the URL itself, which many banks and many websites did for many years, they still do it. They just add a protection to it. Then it looks like Alice, like it actually, from the bank's perspective, it's no different than if Alice logged in, went to her checking account, filled out the form, like transfer this money. When she hits the button at the end of the day, the banking website's going to create this exact URL, right? So it looks exactly the same. The adversary knows this. He has an account at the same bank, or she in this case. And so she knows what these URLs look like, so she's able to craft that perfect URL for this particular bank. And then she's just crossing her fingers that someone lands on her page that happens to be logged in to the bank at the time that they do it, and they have $100 in their account, right? And if that happens, then the money gets transferred.
Okay.
Yeah.
What is the usage of cookie here?
So the main point is that when I open up the request, so when I post this, when I request this URL from the bank, I'm logged in. And so because I have a cookie, my browser doesn't know that, oh, this request is coming from inside an iframe, right? My browser just says, oh, this is a request going to bank.com. I know when I go through my cookie jar, I have a bunch of cookies for bank.com, so I'll send them along. And same with the bank. The bank doesn't know that this request came from an iframe. It just sees a request, right? And so no one really knows that there's something weird going on.
And what the user sees just the normal bank page and this URL?
So the user would see the Evo website, so whatever I have on this. So it could just be a news article or something. Like it doesn't have to have anything to do with anything. And this iframe, like I said, it could be 1 pixel by 1 pixel. So it could be smaller than you could see with your eye. And so the user wouldn't see anything. They would just go to a news website, and then they would go somewhere else on the web, and the money's gone, but they don't know it. Like there's no, the user's not in the loop at all.
I think user click on the
Yeah, so you don't even have to click in this case. We'll talk about that later. So there is another attack called clickjacking, which is kind of similar to a cross-site request. But anyways, yeah. In this one, it's silent. So you go to the website and it happens, and you don't even know that it happens. Okay, so the key points are that this URL is, Eve chooses this URL, so she can put whatever she wants in it. And the type of URL are called RESTful, and so like here's the example that we have where we have the search query. And yeah, so we call them stateless websites because they don't have to remember anything about you. Okay, you just always create a new URL with whatever the user. So if the user is looking at page 1, then all the links to all the other pages already have those parameters built into the URL when you download the website. Okay, so how can we solve this particular issue? So there's a bunch of different ways of solving it. Some of them were like, oh, maybe you shouldn't do cross-site requests from frames. Like maybe the browser should step in, or maybe websites could have policies like cookie policies that say, if the cookie's being sent in a frame, then don't send the cookie, right? Only send it if it's coming from the website itself. Things like that. So there's a bunch of stuff, and some of that took off, and there's some policy languages and things like that that let you specify more verbose things about what you want to happen. Okay, but the solution that kind of won at the end of the day, because it's pretty simple, is let me just go back here. So by the way, this does not use it. So there's no security protection here. Now, there's nothing sensitive happening here other than I'm looking at a page. If I try and message people and things like that, I'm not sure how Moodle works. But anyways, in Bing.com, you can see they put a whole bunch of stuff in the URL. But there's this one thing that I'm guessing is what we're about to talk about. I can't be 100% sure, but based on the name of it, it's called CVID, and it's a bunch of hex characters. Okay, so what the solution is, it will look kind of crazy at first, but we have to think through why it works. Is what the bank will do is they'll say, okay, we're going to do this RESTful thing. Okay, we're going to use these RESTful URLs. We'll let you transfer money by putting it in the parameter, but what we want is at the end of the URL is we want you to repeat what your cookie value is. Okay, so if you have a session ID and you're logged in, you have some cookie with us, and that cookie's getting sent anyways. Okay, so we'll talk about why. This is why it sounds kind of strange. But what you're going to do is you're going to put that cookie also in the URL, right, at the end or wherever you want to. Okay, now why does this work? So imagine you're the adversary. Okay, so you're the adversary here, and you're allowed to choose this URL. You can choose it to be whatever you want. Do you know the user's cookie value? Okay, so you cannot stick that cookie value at the end. Okay, but that cookie is being, you're creating this iframe and the cookie's getting sent, right? So why can't you just read the cookie out of the request? How do you not know the cookie? How's this cookie getting sent if you don't know it?
It's added by the browser once the request leaves.
Okay, so your browser's the one that's putting the cookie here. Okay, so the website doesn't know it. Only your browser knows the cookie, and your browser's putting the cookie there. Okay, so the user, and you can't ask the browser for the cookie either. Okay, you can to some extent, but that's also governed by same origin. So you 100% cannot ask if you're a website, hey, what's Facebook's cookie for this user or whatever. Okay, so there's no way for the attacker to know the cookie. The attacker can't get the cookie, but the cookie's actually being used, right? So it seems like a contradiction. The cookie's getting sent by a website that was created by the attacker, but the attacker doesn't know the cookie. So it's only possible because the browser's the one that's putting the cookie there. Okay, so the adversary is controlling everything that's in the request, but it's the browser that's dropping the cookie in front of the request, and the website can't do that. Okay, so then the bank will say, okay, you know what? This URL just came in the front door. There's no cookie attached with it, or the cookie doesn't match the actual user's cookie, right? Then I'm just going to ignore it. Okay. Then if you do a cross-site request, then you can't possibly do it. Okay. All right. So so bank.com, you put the cookie on the end. The request comes in. Okay, and the request is. The request is created by Eve. And the cookie is placed by the browser. Okay. Now you see some HTTPS stuff. So the other question is, okay, let's say you're the adversary and so you do this attack and now you're stuck because you don't know the cookie value. But let's say that you're also able to monitor the network connection. So you're able to sit on the wire so you see these requests go by back and forth. Then could you do the attack? Could you save the attack? Okay. And so the answer is if it's over HTTP, then yes, you could. You would see the cookie go by, you could pull it out. But if it's over HTTPS, right, would you or would you not see the cookie? And so the answer is you wouldn't see the cookie in either location. So the cookie's showing up in two spots. This is why it's slightly complicated. Sorry, the scrolling, I've mentioned this before, but it goes crazy when I screen share. Okay, so the header that's the cookie that's placed in the request, appended to the request, is covered by HTTPS. So we mentioned this before when we talked about cookies. It has to be that way, otherwise you couldn't use cookie. Anyone could steal anyone's cookie just by listening to their traffic, okay? And when I request this URL, let's say I'm actually dealing with the real bank. So the adversary sees me go to the bank for real, then they're going to attack me after. When I go to the bank for real, I'm putting my cookie at the end of every URL. Isn't that dangerous? Right? If anyone can read that URL, then they have my cookie and they can hijack my session, right? And so the answer is, well, HTTPS covers the path. So it doesn't cover the domain that I'm going to because the packet has to get to the right domain, but the path that I'm going to within that domain, that is covered by HTTPS, okay? So putting these cookies in the URL parameters isn't dangerous and then sending them as long as you're using HTTPS. Okay, questions about cross-site request forgeries? Okay. Okay, so all of this is leading us towards what's called the same origin policy. So the same origin policy is the same as the cookie policy for browsers. So cookie policy is basically like the browser's looking at a website and its requests that's going out, and it's trying to decide, should I attach this cookie or not to it? So I have 500 cookies, a request is going out, which of the 500 cookies should I put in this request? And so I have this rule that tells me, like, do the domain names match, and what was specified in the cookie itself, and all of these. Is it going over HTTPS and not? So we went through all of that. So the browser does the exact same thing for cookies. It does the exact same thing for actually every resource that's on a website. So websites, they have images, they have HTML, they have some JavaScript that's running. There's lots of stuff happening within a website. And in particular, JavaScript can ask to basically rewrite different resources on the website. So JavaScript could pull an image in. Or if you pulled an image down over just an HTML request, JavaScript could say, actually, get rid of that image and put another image in its place. Okay? So every resource could be rewritten in theory by scripting. So scripting is very dangerous, by the way. If you get bad scripting on your website, right, then it can basically rewrite the whole website. Okay? But when we have iframes, then that also kind of isolates things, okay? So we need to write down some rules for, like, when is JavaScript from site A allowed to talk to JavaScript from site B, and can they write over each other's resources, and does it make a difference if it's embedded in the page or if it's in an iframe? Like, what are all the rules, okay? So that's what the same origin policy is. It's basically just what all the rules are about it. So it governs how resources on a website are isolated from each other. And the way it works is when you go to a website, we saw, like, well, just look. So I go to a website like this. And you can see all the stuff that comes down. Like there's an HTML page, there's JavaScript, there's SVG's a type of image, there's some text that comes down. So all of these things are resources that are on this website at this particular time. Okay, and what this is actually showing me is what the browser does, which is the browser goes in and they tag every resource. So they say, okay, you just loaded this SVG. This is where it came from. This is the name, the file name of it. This is where it came from. And it remembers this. Okay, it stores it in this thing called the DOM tree, which you can't really see very well with this. Like you can see the DOM tree, but it just looks like it doesn't look intuitive. But anyways, it stores it in a data structure so that it can figure out later. So let's say in JavaScript, you're like, oh, I want to overwrite that image. Then it will say, well, wait a minute, do you have permission to do that or not? Then it has to know, well, did this image come from the same place as the JavaScript and other stuff like that, okay? So scripts can access both read and write all the resources that are in the DOM tree. But what the browser is going to do is it's going to say, you're only allowed to overwrite the parts of the tree that are from the same origin as you, okay? You can't write stuff or read stuff from other parts of the tree. Now, this whole tree thing doesn't matter. It's just a data structure, okay? So what are the resources that we're talking about? So we've gone through this before, but it's things like images. So this is passive content. Scripts, this is active content. HTML files are passive. CSS are sort of in between, but we treat them as if they're active. You have things like frames that we'll talk about itself, okay? So let's say I download a piece of JavaScript. What does my browser remember about that JavaScript? It remembers basically the origin of it. And so the origin specified as first off, the domain name that I got it from. So incs.concordia.ca, that's where the JavaScript came from. So I'm going to remember that. It also remembers the sort of the protocol. So here it's HTTP. It could be HTTPS. It could be FTP. There's some other obscure things. And so nowadays it's just HTTP or HTTPS, okay? And all HTTP comes over port 80, okay? But if you downloaded one piece of JavaScript over port 80 and for whatever reason you asked for it over port 40, a second piece of JavaScript, and your browser pulled it, it asked the server and the server said, fine, I have this sitting for you on port 40, and you pulled it in. Even if they came from the same place, the browser would say, actually, these are different origins. Okay? But the main point here is that the URL matches. So anything from matching domain names, and it's not path names, we ignore them, just from matching domain names, they're going to be considered same origin. Okay? Very similar to how cookies work. Now, you can override the domain if you want, okay? And so the rule is that you can go up domains, all right? So if I want, like say I'm loading something from images.concordia.ca, but I want some JavaScript from scripts.concordia.ca to be able to have access to it, read-write access to it, then what I can do is I can set the domain for both of those to be the super domain, which is concordia.ca. Okay, if I set it to concordia.ca, then then they have matching domains. Okay, and so if I set document.domain, I can always move up. But then what it does is it puts a flag. Okay, and the flag's important because if I have a resource that's truly from concordia.ca, but I didn't override the domain of it, and if I have another resource that's from some other thing and then it overrides the domain to make it from concordia.ca, those will be isolated from each other. So my browser will say, okay, they look the same, they came to the same port, they're the same domain and everything, but one of them, I got to that domain because it was overridden. In the other case, I didn't override it. So I'm going to treat them as differently, okay? And it's meant to like stop people from, like subdomains from accessing, like it's sort of a way of making sure that both the superdomain and the subdomain give permission to each other in both directions to access each other's resources, okay? Now, if you want those two resources to talk, it's just as easy as you can override the domain but set it to the same domain that you're already at, right? So most web developers are lazy, so they'll just always override the domain and always just make it the current domain, unless if they know specifically what they want to do in their heads. Okay, so path names don't matter. So Clark/index.html and Manon./index.html, these are considered same origin. They're both over HTTPS. We're going to assume they came over the same port, which is 443 for HTTPS. If I go to the same domain, but now I'm over HTTP, right? That's a different protocol. It's going to go over a different port as well, incidentally, port 80. And so that's going to be considered a different origin, okay? And if I go to a different subdomain, so for example, CISE.concordia.ca, it's not the same subdomain, therefore it's not going to be considered the same origin. Now, if I wanted this, if this website, the fourth one and the first one, wanted to be, if they wanted to share resources, then they could both override it and set domain to be concordia.ca. Then they'd be able to share resources, okay? And they're both allowed to do that because they're strict subdomains of concordia.ca, which is what they're setting for.
Sorry, in which case you said that even with overriding the server doesn't allow to, what is the example in this case?
Yeah. Okay, let me add an example. Okay, let's compare these two. So this one's at users.encs.concordia.ca, and this one's at encs.concordia.ca. They're both meant to be over HTTPS. Let me fix that. Okay, are these the same origin? They are not, because this has a users dot in front. Okay, so this is a different subdomain. So they're not the same yet. Okay. Now, what this person might do is they might say, I want to set domain. I forget the document.domains, the syntax. To encs.concordia.ca. This is allowed to do that because it's a subdomain of it. Okay. Now, okay, so these are not the same. But if I do this, now are they the same or not? Okay. And so the answer is yes, they're the same protocol. Yes, they're the same subdomain now. Yes, they're both over port 80 or 443 because it's HTTPS. But one of them overrid. One of them got to this domain by doing an override. The other one did not. Okay? So they're still not the same origin. Need to stop scrolling around. Anyways, okay, so they're not the same origin because one of them will be overridden and one of them won't. Okay. Now, if I want to make them the same origin, then I can override the second one as well in the same way as the first one. So I can override it and have it point to the same domain that it was already at. So I'm not changing anything about the website. I'm just adding that flag that it was overridden. And then it would talk to each other.
The second domain will change to also override to users at INSE.
Yeah, exactly. Yeah. All right. Very gingerly, I got back here. Yeah. So if this website also did set document domain to this, right? It didn't actually change anything. It would just add the flag to the origin. Then these two things would finally be the same.
So both the websites should have the override on with the same document.
Exactly. Yeah.
Is it always necessary to have like same origin for the two websites?
So it depends. So some cases you want it, in some cases you don't. The reason you don't want it is usually because of some security reason. Right, so you don't want these two domains seeing each other, reading and writing each other's stuff, right? The main reason you want it is because you're trying to build a website and your scripts are coming from some place and other stuff's coming from other places and you need it all to interoperate, right? And so usually what happened traditionally is that web developers would just always set their domain to the top level domain, like the biggest, the broadest domain that they could do. So you can't go all the way to .com just like in cookies, but you can always set your domain to like concordia.ca or whatever the top level domain is. Sorry, that's not a top level domain, that's just a domain. You can't go all the way to the top level domain, which is just .ca, but you can go to a domain. And so developers would just turn that on for everything. And then it has the maximal chance of interoperating. If you have like resources from two different URLs, then you're in trouble, right? But otherwise, it basically will always interoperate. Okay. But then it was bad for security because now everything's talking to each other anyways, right? So you can like go on Stack Overflow or whatever and read 1,000 posts of like, hey, I'm trying to get these things to talk. It's not working. The answer is, just go set document.domain to the top or to the domain itself, which is sort of the answer that always works, but it's not always the most secure. Okay, so we talked a little bit about iframes. So iframes are one way to bring content into a website, but it's not the only way to do it. Okay, so there's basically three ways that you might bring content in. So here's a website. Its origin is whatever, concordia.ca, and it's a website, okay? Now, what you can do is you can get JavaScript into the website, well, 3 ways, okay? So one way you can do it is you can use the script tag, okay? So you can put script and script, and then you can put the actual JavaScript itself, okay? So what goes inside this script, right, is the actual JavaScript itself. So the JavaScript is in line with the website. So when I download the website, the JavaScript comes with it because it's baked into the HTML. It's hard-coded into the HTML itself, okay? So that's the first way that you get it. Now, what's the origin of that JavaScript compared to the website? If I'm getting the website from concordia.ca and it has JavaScript that's hard-coded inside of it, is that JavaScript also from the domain concordia.ca? So the answer should be yes, right? It's in line with the website. It's right in the HTML, so obviously it's the same, okay? All right. Now, the next example is I could pull the JavaScript from a URL. So instead of saying, here's the JavaScript that's right in the HTML, the JavaScript will be in a file, right? And I'll point to it, right? And so I still use the same script tag, but basically we call that embedding. So this is an inline script. This is an embedded script. So an embedded script might be, hey, go grab script.javascript or script.javascript, yeah, .js from concordia.ca/script.js and put that in this page, okay? Now, the page that's requesting it is concordia.ca, right? And we're pulling the JavaScript in from concordia.ca, so the origin, once again, is going to be concordia.ca, right? Okay, now a more common example is I'll pull in the JavaScript, but I'm going to pull it in from some other domain, right? So for example, the JavaScript is hosted on GitHub. It's a very common library. Everybody uses it. And so I want to use it on my website as well. So I say, okay, here's the website. Now I want to run some JavaScript. So go over to GitHub and grab this JavaScript file from GitHub, okay? Now the question to you is, when the website puts that, when my browser dumps that JavaScript into the website, what does it mark as the origin of that? Is the origin of that github.com because that's where I got the scripting from? Or is it concordia.ca because that's where I'm dumping the JavaScript into? All right, who thinks GitHub should be the origin? Okay, who thinks Concordia should be the origin? Who has no opinion? Okay, so the answer is this is what's counterintuitive, okay? And this leads to another whole class of vulnerabilities called cross-site scripting, which I'm sure you've heard of. And the answer is that your intuition probably says it's GitHub because I'm getting it from GitHub. But the answer is no, it actually is given the origin of concordia.ca. So why is this given the origin of concordia.ca? Well, the answer is that, you know, it's just think of it, it's really not, embedding scripting isn't really that different than running it in line, right? If I hard-coded the script here, right, then it's clear that this origin should be concordia.ca. Now, if I say go over to GitHub and copy and paste this JavaScript into my website, right? If I say copy and paste it into here, like whatever the content of this file is, just copy and paste it into these scripting tags and then run it, then it's still going to be origin concordia.ca, right? And so when I say go grab JavaScript from over wherever, that's the mental model that the browser has for you. It's as if you copied and pasted that code into your website, okay? So it's going to run it as if it were copy and pasted in. So code that's embedded is treated just like it was in line, okay? So the browser just says, you want code, I don't care that it's coming from GitHub, you're trying to run it on concordia.ca, right? And so I want to, I'm going to treat it just like you copied and pasted that code into the HTML, okay? That's the way I'm going to treat it, and that's the way it's going to run. Okay, does that make sense? Okay, so that's the sort of mental model for how it works. Now, you could think about the opposite. Let's say we went the other way and said, oh, let's treat this like GitHub, right? Does that make a lot of sense? Like, say I have a database and there's some GitHub code that lets me search my database, right? But then when I copy the code into my website, the code can't access the database because the code is running on GitHub, right? But the database is on my website. No, like I want to pull the code in. I want it to work with my website. That's why I'm running it on my website, right? Or conversely, let's say that I pull the script in from GitHub and I start asking about, I don't know, cookies or something like that. Is it going to start telling me all of GitHub's cookies? No, right? I'm pulling the script into my website, right? So I don't want the permissions of GitHub. I shouldn't be given the permissions of GitHub just because I got this random JavaScript file from GitHub. Okay, so that's the biggest sort of mental model block that a lot of developers got wrong. They didn't realize is that when you pull a script in from somewhere, it runs with the permissions of the website that called it. Okay, not the permissions of where it's actually from itself. Okay, so where it's from is irrelevant. Okay, so just ignore this stuff here for a sec. But anyways, so all scripts share the same execution environment. Okay, so it doesn't matter if the script came from Concordia or if it came from GitHub. It's all assigned the same origin, which is concordia.ca. And both of these scripts can access every other resource that's also marked as being from concordia.ca. Okay. So the right mental model for this is just think that the script was copy and pasted into the website. That's how it should work, okay? And we call this a cross-site script. So you might think of that as an attack. There is an attack with the same name, but at this point it's not an attack, it's just what it is. It's a script that came from one website that's being run on a different website. So it's a cross-site script. That's all it is. But cross-site scripts are powerful because basically, whatever the user's doing on this website, like if they're typing in passwords or things like that, the JavaScript can monitor. Okay, it can see whatever. If you're loading your email or whatever, you can. It can have access to all of that stuff. It can even ask for cookies and do things like that. Okay, so if you get bad JavaScript running on your website, it basically compromises. By the website, I mean like what the user's seeing in their browser. So everything, it's not like the website's back end, right? It's not like it can't corrupt that. But whatever the user's seeing in their browser or whatever they're capable of requesting through requests, then the JavaScript they can see all of that information. Okay, and JavaScript can also do cross-site request forgeries because they can also create URLs, right? So if they think that you're logged into Facebook, they can start generating Facebook URLs, okay? And you'll note, if you remember way back last class, when we talked about cookies, there was the secure flag, right? Which is whether it should be sent over HTTPS only or you can send it over HTTP. And then there was the other flag, which was HTTP only, and it said don't let JavaScript, don't put these cookies on any JavaScript requests, okay? Why is that? It's because of this. Okay, it's because JavaScript is so powerful that it could take over a website and then it could start spawning lots of URLs. And so what you can do in your cookies is you can say, you know, don't ever send this cookie if JavaScript is creating the URL. Okay, only send it if it's actually from a request that was created by the browser by doing HTML like kinds of stuff, like requests and responses with the websites. Okay. Then the final bit we have is an iframe, which we also saw, okay? Now, if I put JavaScript in an iframe, right, does it run with the permissions of, is it assigned the origin of concordia.ca, or is it assigned the origin of whatever the iframe is? Okay, so it's going to be of the iframe itself, okay? So iframes are more powerful in terms of isolating than embedding. So if I pull script in and I dump it in the website, there's no boundaries between that script and the website itself. If I pull it into an iframe, then there are boundaries and the browser enforces it. Okay? So if the iframe is for facebook.com, the origin is for facebook.com, and this is just now like a little mini website site. Okay? So all of these rules also apply. So if Facebook, in filling in this iframe, They pull JavaScript from GitHub. That JavaScript's going to run with the origin of Facebook in the same way, okay? So this website, it's just like a mini website inside the website inside, okay? So the script can't bounce out of the iframe. So the scripts that are running here can't ask to see or write to any of the resources in the outer website, and vice versa. So the outer website can't ask to see what's happening in the iframe. It can't see that two of your friends like the Facebook article or whatever, and it can't overwrite it either.
It's like the like button.
It is, yeah. This is the like button, exactly. Yeah, it's the exact same example, yeah. Okay, so script inside the frame is isolated from scripts on Concordia.ca, and then Concordia is also isolated from scripts from Facebook. So basically, they can't see each other. They can't write it. So Facebook data is safe and private from Concordia. So that's why Facebook will let any website embed a like button in it, because it's no danger to Facebook. It's isolated. Yeah.
So if they don't have any interaction with each other, you have an example that attacker run bank.com
Yeah.
as iframe,
Yeah.
and they use the cookies and URL and everything from there. So how, if they are
It's a good question. So if these are separated, how is it that they can communicate to each other? So the answer is they cannot communicate in any way. They're completely isolated, with one exception. The exception is that that this website gets to choose where the iframe is pointed at, right? So if this is an iframe for Facebook.com, that was chosen by Concordia.ca. They chose to put an iframe and have it point to Facebook.com. So that's the only communication that you can do between the two, right? Is the parent site is allowed to choose the URL of the child site, and beyond that, there's no interaction, no message, no resources that are shared. Okay. Now, why did that work in the bank example? Well, choosing the URL was enough, because we put the fact that we wanted the money transferred into the URL. The browser put the cookie on the URL, and then that was enough for the attack to happen. So just that one little tiny bit of like, I get to choose the URL that you go to in the iframe, that was powerful enough to make an attack. Yeah, but it wasn't because they were communicating with each other. Okay. Now sometimes you do want things to communicate. You do want communication between the outside website and the frame, or if you have more than one frame, communication between different frames on the same website. So is there a way to override it? And the answer is yes. So there's this post message protocol that you can use, but both sides have to authorize it. Okay, so it's not enough for just one of them. Both of them have to say, okay, we're willing. They basically both point at each other as like authorized domains for receiving messages. And then there's some limitations to what you can do with post message. But anyways, you can get two websites talking to each other if you want to, and if both of them agree to it.
So this post message is something like set document domain.
Yeah, exactly. Yeah, it's the same. Like the override is the same. Yeah. And it's both things. It's both like browser-based things that you set through JavaScript, essentially. So yeah. Okay. Other questions? Okay. Let's take a 10-minute break, and then I'll show you how to attack using cross-site scripts. Okay. So cross-site scripts. Remember, they're a thing, not necessarily a negative thing, but they could be weaponized. Okay. In particular, think about a website. Like say someone's Gmail account, the user's there, they're on Gmail. If you can get your script running on Gmail, on the user's browser, with the same origin, right, as Gmail, right, then you can read their email or do whatever you want to, okay? So the idea of injecting scripts into websites is dangerous. Okay, so let's say that our goal as an adversary is just to get our own JavaScript running in the context of a website that we want to attack. Once again, I want to emphasize you're not attacking Google's backend, okay? You're just attacking the instance of the website that's running in the user's browser. So when the user's looking at whatever the user can see in their browser, then your script could also see. Okay, but it's different than, it's not like you're dumping the database of Gmail in the back. Okay, so how can you do this? What are and so the answer is there's 100 different ways. You're going to take a course like 6120 or 30 or 40, whatever the networking one is, and you'll probably learn like 10 different ways of doing it. I just want to show you a couple just so that you get the sense, kind of like with attacking HTTPS, is there's a lot of different ways to do it. They're not all technical. Some of them are more social or whatever, and they all have the same net result. Okay, so probably the most common is you find some JavaScript library that everybody's using, and if you're able to overwrite it, so let's say it's being hosted on GitHub and you're able to steal the password for the developer of that website or someone that has commit access to it, then you can corrupt it, right? Or maybe you make a mirror of that protocol. So you say, okay, I have a server and I'm also hosting this JavaScript, and my server is really fast and it's super responsive. And you spend a year actually hosting the real JavaScript, and then all of a sudden people start using your mirror of it because you're very responsive. And then you decide to go bad and go rogue, and then you change the JavaScript at some point. Okay, then everybody whose website is pointed at your library, they're now running the malicious JavaScript, right? Or if I can breach your website because you're hosting it some other way, maybe I change the DNS record for your website. You know, basically any way you can take over a website or take over a user account that's hosting stuff on a website, you could use that to overwrite a popular JavaScript library, and then now you have malicious JavaScript that's running on any other website that's pulling that JavaScript in and embedding it in their own particular websites. Okay, so that's usually today what happens, but there's other ways of doing it that are kind of more technical and kind of more obscure. Some of them have been fixed or not, but anyways. Okay, another thing that used to work is you would just sit back and you'd be, let's say you're a man-in-the-middle adversary, and if you saw any JavaScript go over HTTP, guess what? You can overwrite it, right? It's HTTP, you can see it, it's in clear text. There's no signatures or MACs or anything on it, so you can also change the content, and then you stick your malicious addition to the script into it, and then that gets sent down to the browser, and the browser loads it, and it doesn't know any different, okay? And so this is so dangerous that now, as we've mentioned many times before, browsers do not let you load JavaScript that's not served over HTTPS, okay? If it's served over HTTPS, then you at least have that guarantee that it wasn't changed by the network between you and the website. It doesn't protect you from the first attack, right? HTTPS doesn't, if the script is bad on the website itself, right? HTTPS just says, well, it wasn't modified, like what the website sent you and what you received is exactly the same, right? It wasn't modified. But anyways, this is also an interesting example where, like normally when we think of HTTPS, we think of it as providing secrecy, right? Here, you don't even care about secrecy. It's a public file. Anyone with that URL can go get a copy of it. What you really care about is integrity, right? That message wasn't changed between the server and the website. And so this is an example where that's the feature of HTTPS that you really want, is the integrity. You don't really actually even care about the secrecy itself. Okay. The next way of doing it is the kind of traditional cross-site scripting attack. And so the way it worked, like, I don't know, in the 2000s or even earlier in the 90s, is you would go to websites like, for example, I remember in the 90s, I would go to a website and they would have this thing called a guest book. And like the web was like so weird, and like there was hardly any people using it and things like that, that if you put up a website and some user actually ended up on your website, they could like leave a message to you on your website, okay? And this worked through posts, so that post request that we talked about before. So I would type a message and then I would post it, and then it would store it on the guest book, and then other users who come to the website can look at the guest book as well, okay? Then what people started doing is they started putting JavaScript into the guest book, right? So they would sign a message, but it would actually have JavaScript that's contained in it, okay? Then when another user came to the website and they said, show me the guest book, right? It would take all the entries from the database and it would dump it in line in the HTML website. And so when it hit that JavaScript, and you would wrap it in a script tag. So you would like post, instead of saying, hi, it's Jeremy from Montreal, you would say script, you know, blah, 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 like /script or whatever. You put it there. And so it would get weaved into the content of the page. And then the browser would think, it would hit that tag and it would say, oh, I'm supposed to execute this script now, right? And then it would execute. It's executing in the context of that website, right? And it will do whatever the JavaScript tells it to do, okay? So the example is sort of like, or let's say there's like, I'm creating a profile, like I'm filling out my profile on Twitter, and I just dump some JavaScript or something in it. Then when you come to my website and you see my bio, then there'll be some JavaScript there. And if I can confuse your browser into thinking it needs to execute that JavaScript, so that depends on how the website is programmed. But it turns out it's very easy. Browsers get, like there's no separation between, oh, this is code and this is data, right? HTML, it's just like, the only thing that separates code from data is this special tag script, right? That's the only thing. So normally your browser would just execute it straight up, okay? So we call this now persistent cross-site scripting because it sticks there forever and everybody else that goes to the website sees it. Probably one of the earliest viruses or worms, they called them worms back then, I don't know why. Now we just call it malware. One of the earliest examples of malware was a cross-site scripting attack. It was on, I think it was on MySpace, which was like a predecessor to Facebook. But basically, someone figured out that it was vulnerable to cross-site scripting. And so they wrote some scripting into the bio that if you went to their website and looked at their bio, you would automatically friend them. And then you would also post that JavaScript to your own bio so that anyone that looked at your profile would automatically friend this person again. And so the person posted it, and then they started getting all these friends requests, and then the whole service came down because they were coming in so fast and everyone was changing their bios. And then if I recall, it was a he, and he was charged criminally with hacking just for doing that. Now we probably wouldn't think that much of it, but back then everyone was like petrified of hackers and things like that. So anyway, that was the first kind of worm because it replicated. So the code, it copied, it wasn't just his own profile, it like copied from his profile to your profile. And so it had this sort of replication. But anyway, so we call it persistent cross-site scripting. Now this is very hard to do on the web today, okay? Everyone uses frameworks. All the frameworks throw the whole like kitchen sink at like trying to solve this problem. So they'll sanitize your inputs. So they'll say, you cannot use a triangle bracket. That triangle bracket could be confused for an HTML tag. You cannot use it, period, okay? And certainly if you use the word script or like inside that, like it will sanitize all of that types of stuff. They try to separate code from data, from like things that should just be content of the website. So there's a bunch of tricks for doing that as well so that you never unintentionally execute things. Obviously, you can go to like some sort of HTML help website, and the help website would show you something like this. Like if you're like, hey, how do I use a script tag? Right? You're looking at the website, it has a script tag. So there is a way to render it and show it to the user without the user's browser thinking I need to execute this, okay? So there are ways to present HTML tags without the user thinking that they need to execute it. So anyways, it will use that type of thing as well. But yeah. Okay, another one is called reflected cross-site scripting. So this goes back to like the example we gave before, where you have some search query like CF Montreal, so you're going to search, and that's going to be put in the URL itself, right? Now remember, if I copy and paste that URL and I send it to you, and you click on it, right, then you're going to go to that exact same search result, okay? So the question is, could we weaponize that somehow? Well, what if we kind of like put JavaScript up in the URL? Sounds kind of weird. Maybe we encode it in base64 or something like that. But what if we just put a bunch of JavaScript in this URL? Okay. And then I trick you to go to that URL. I send you an email, say, check out these search results, right? You're not looking closely at the URL. You just click it. Then you go here, and there's some JavaScript up there. Now, JavaScript in the URL, that's not going to do anything, right? Because the URL is just you asking Concordia.ca, in this case, give me the search results for this weird string, right? And so what are you going to see as the search results? You're going to see like, oh, I've never even heard of that search query before. Like there's 0 results, okay? But what some websites will do is they won't just say, oh, there's 0 results for that search. They might say there's 0 results for your search, and then they'll repeat what the term is that you searched for, okay? So like I searched for CF Montreal. It says we found 100 results for CF Montreal, and it just copied and pasted what was in the URL into the website, okay? So there's a bunch of JavaScript sitting here in scripting tags. There is a chance that maybe when you see that results page, they grab that query and they embed it in the page. So it says, oh, there's 0 results for copy and paste what you actually searched for, which has a scripting in it, right? And then when you render it in your browser's like blah, 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 0 results for, and then it sees the script tag and it's like, okay, now I need to load that JavaScript, okay? So this is called reflected because it reflects in the URL. It involves me tricking you, so you have to go to a badly constructed URL, and it also requires websites to copy stuff from the URLs into the content of the website blindly, right? They don't know what they're doing, but anyway, so that's another example. Questions about any of these so far? Okay, the last one is just, so these are the simple, like the top 4, I would say. So you hack the JavaScript library. This one's solved. You replace it when it goes over HTTP. This one's more or less solved because everyone uses frameworks and everyone's checking everything. But every now and then you still hear about a persistent cross-site scripting attack because sometimes they're in like weird locations. And then reflected was popular for a while. Okay, so these are the kind of the 4 simplest ones. And then I just wanted to show you one example from the other extreme, like a really complicated example. It's not even that complicated, but a more complicated example. And there's a lot of attacks in between. So there's all sorts of different cross-site scripting attacks. But this is an example of, adversaries being very creative about what you can do with cross-site scripting. So that's a good question. So the solution here is really just to do the same thing. Whenever you copy data from a URL and you're about to display it to the user, you run it through the same kind of filters you would for any. So the websites will call it user-supplied strings, right? So any string that's user-supplied is treated a certain way. So it's always put through the same library, and that library is going to sanitize it. And it will do the same things. It will say, you can't use this triangle bracket. You definitely can't use any tags. Sometimes they'll let you use an image tag or something like that, but they'll look for that type of thing. Then people will do some weird Unicode, instead of using the bracket, they'll encode it as a character. Or sometimes you can get strings that rewrite themselves or things like that. And so people will try all sorts of tricks, but then people will see it in the wild, and then the developers will say, okay, we need to fix our filter to filter that out. And so it's kind of this cat and mouse that goes back and forth. But eventually you end up with things like WordPress. I think they actually ask you to hack WordPress, but early versions of it for cross-site scripting. But something like WordPress today, the most current version, you would have a very hard time trying to get something past the filters that they use. Yeah. But anyways, it's the same defense as up here. You filter the user supplied string. Yeah. Okay. So the last one I'll talk about is second last, sorry, is self-infected cross-site scripting, and it goes back to the persistent. It's a variant on the persistent cross-site scripting. So what happened is people started doing these persistent cross-site scriptings, and then every website knew, okay, I have to be really careful anytime I take data from the user and I display it to another user. If I take data from you, you supplied that string, and I'm going to show it to someone else, right? Then I need to sanitize that, okay? So then we went through a phase where almost all public-facing user-supplied text had been sanitized, okay? But there was always this question of, what if there's text where it only gets displayed to me? So I'm the user, I supply the data, like say it's an administrative panel, right? So I put some like information, like say my email address. It asks for my email address, but it never displays my email addresses to other users, right? If I go into my own system settings, it will say, okay, this is the email address that we've recorded for you, okay? So that's information that's only displayed to me. It's not displayed to any other user under any condition, okay? And there's a lot of text that's collected by websites that are sort of in administrative panels and things like that, where the user that supplied the string is the only user that can see it. So for a long time, people thought, well, we don't, like, obviously we want to just deal with cross-site scripting across the board, but if we have a vulnerability like in an administrative panel or something like that, who cares, right? The user could run a cross-site scripting attack on themselves, right? So instead of storing my real email, I could stick a JavaScript, and then when I look at my own profile, it shows this JavaScript instead, and then it runs, and then now I've infected myself. But like, who cares? Like, I've infected myself. You might say, well, then maybe I can like manipulate the website or something. You can inject any JavaScript you want into any website. Like I can download a website and just say, here's some JavaScript I want you to run, right? So there's basically nothing to it. But then someone came up with a very creative solution. They said, oh no, we have a way to like kind of weaponize this. And so anyway, so this just shows you how far people will go with cross-site scripting. So don't worry about the text for now. Just think about the page itself. Okay, so let's say first off that there's some page that has this admin panel. Okay. Okay, so I call it social media in the example. So let's say, so there's some social media page, and it has this cross-site scripting vulnerability, but it's in an administrative panel that only I can see, okay? How can I attack you with something that only I can see, okay? So what I'll do is I'll do a standard cross-site request forgery kind of attack. So I'm going to trick you into coming to my website. I'm going to load an iframe. The iframe is going to be pointed at that social media website. And if you're logged in, then you immediately log in inside that iframe. Okay, so your account information is the one that's being shown. All right. Now, that's not dangerous yet. Okay, there's nothing dangerous about that. That's just a standard cross-site request. Okay, it's not even a forgery. It's just a cross-site request. Okay. Now, the variation that I'm going to do is I'm going to actually do this twice. Okay. What I'm going to do is I'm going to load the first iframe, and I'm going to let it load. So it's going to load, and your user profile is now sitting in that iframe. Okay. Then, assuming I can do an action like log out or log in through the URL, right? What I'll do is I'll create a second iframe, okay? And I'll send a log out request through that second iframe, okay? So it will go to the social media. It will then log out, and then I'll log myself in. The attacker will log themselves into that second iframe, okay? So now we have two iframes. The first is the user's original account. They're now logged out, but whatever they loaded is still sitting in that iframe. So think about it like their inbox. You're attacking Gmail or something. Or, well, we said social media, so it's like your Twitter DMs, right? So their DMs are still sitting there. They're logged out, so you can't really start clicking on them, or it will say, okay, you got to log in again, okay? But they're sitting there. If I load a second iframe, then if I can log the original user out, log myself in, and then go to that administrative panel where there's the cross-site scripting vulnerability and it's sitting there, then my JavaScript starts running, okay? Now, my JavaScript is running in the second iframe, right? But what's the origin for it? So the origin for it will be the social media website, okay? And Alice's profile, her DMs, which are sitting in this first iframe, what's the origin of them? It's also the social media site, okay? So are these the same origin? The answer is yes. They're in separate iframes, but that doesn't matter. They're still within the same origin. They're still within the same website. And things from the same origin can talk to each other, okay? So I navigate this second frame to my admin panel, which has my bad script in it. Then my bad script starts running, and then my bad script starts asking about, oh, send me everything that's in the DOM tree for Alice's information in the first tree, and go post it to this web server wherever or whatever. Okay, and so I can infiltrate all of that data out of the first iframe and send it off. Okay, so anyways, this is like the most complicated thing that we'll see, but it just goes to show you that you can't really make assumptions like, oh, like we're vulnerable to cross-site scripting, but only the user can see it anyway, so it doesn't matter. You can't do things like that. Okay, so it's better to just try and eliminate the vulnerability across the board and not get clever about whether people can use it or not. Okay, so let me just go through the text and make sure it has everything I said. So assume you have a cross-site scripting vulnerability in an administrative panel that only you can see when you're logged in yourself. So you trick a user into visiting the evil website. The first frame goes to the social media. The user's logged in. Well, initially, I guess they're logged into both. Then you log them out using URL parameters passing. You log them out of the second frame. The adversary logs into the second frame. They go to the admin panel. Then the cross-site script, the persistent cross-site script executes. And then you have a cross-site. It's not even a cross-site request. It's just a same-site request. But you can make a request from this frame into this iframe. And they're both running in the same origin, so you can access each other's resources.
Sorry, Alice here cannot see the vulnerability in the admin panel herself.
So so pretend it's in your. Let's just be more concrete. So when I log into Twitter, my email address contains some JavaScript instead of my real email address. Okay, but I want that JavaScript to run when you're logged into Twitter, because the JavaScript's going to steal all of your DMs, right? Now, if I log into my own Twitter account and see that, and I go to show me my email address, right? It shows me the JavaScript runs, I steal all my own DMs, but I already have my DMs, right? Does that make sense? I want to steal your DMs, right? But if I log into your account and I say, show me your email address, then I'll see your real email address because you don't have the script. I have the script on my profile. You don't have it on your profile. Yeah? So how can I get the script, which is that only I can see when I'm logged in, running when you're logged in? Yeah, so what I do is I log in twice, basically, once with you and once with me. And because of the same origin policy, they're both coming from Twitter. So Twitter's like, you can talk to each other. So I navigate one frame to look at my email address, and then my script starts running, and then it can suck all the data out of the other frame, which is yours. Does that make sense? Yeah. Okay. Now there's lots of details with doing this that I'm glossing over, but this is the high-level principle of the attack. Okay, another attack is clickjacking. And so this is in response to cross-site request forgeries. So what websites did is, just wondering. Okay, so let's go back to this example. So this was the very first example we started with. So we have some news website. There's a Facebook button. Facebook is dumping to friends like this article, okay? And there's also this like button, okay? If I press the like button, it actually goes to Facebook and updates my Facebook profile saying I like this article, okay? So that's fine. Now, what if the news website they want lots of likes, right? So why can't the news article just kind of reach into this iframe and press that like button? If they could just reach in and press the like button, then they're going to get, basically everyone that goes to the news article will automatically like it, right? So 1,000 people visit it. Maybe only 10 of them click like, but now 1,000 of them are clicking like. Okay? So Facebook is going to do two things. First off, they're going to say, you can't like through a URL. Okay, you can't be like, go to this URL /like equals true or whatever. And if the user hits that URL with their cookie and they're logged in, then it's automatically going to like it. Okay, so originally they might have done that. And then because of cross-site request forgeries, they got all sorts of forged likes. Okay, so they said, okay, we're no longer taking likes. What we need from the user is we need a user action. So we need them to actually click on the button. If they click on the button, maybe it still creates that URL and passes it in, but it uses cookie protection or whatever. Basically, we need them to actually click that button. If they don't click it, then there's no way to trick through using URLs, clever URLs. You're not able to trick the user into liking it. Okay. Now, can you with JavaScript reach in and click that like button for the user? Could the news website like reach into that iframe and click the like button for the user just using JavaScript? So the answer is no. It's not because JavaScript isn't powerful. JavaScript is powerful enough to do it. The answer is no because of the same origin policy. So the same origin policy says, well, the outside website can't access the inside website. It doesn't even know that there's a like button sitting there necessarily. It can't see it. Okay? So the news website can't reach in and get the user to click it. Okay, could it do anything to get the user to click it? So the one thing it has going for it is it controls the website itself. It controls what's being presented to the user. Facebook is populating this iframe, but it's populating it within an iframe that the website itself controls. It said, it gave Facebook permission to fill in this iframe. It told Facebook it told the browser how big it should be and all of those details itself. Okay, so the website can't reach in digitally and click it, but maybe they could get the user to actually click it. Okay, so what the website might do. Okay, so you trick the user into going to your bad website. You iframe up Facebook. Alice is logged in because she has a cookie set. And so this is actually Alice's like button. And if she clicks it, it will like this article or whatever it is. And your malicious JavaScript running on the evil website can't go through because of the same origin policy. So the same origin policy, that's meant to be an X and then same origin. And X as in you can't do that. Okay, so what do? Well, you can control the website. You control the layout of the website. So what if you made an image, right? That's like, oh, here, you want to like win some contest. Here's some wheels or something like that. You can spin them like a lottery machine or whatever it is. You'll win $100. And you put that right over the iframe, right? That has the like button underneath it. Then if the user comes and they click this image, does the click go through the image to the like button that's underneath? And so the answer is, because of whatever reason browsers had, is they said, yes, you can make images that have transparent clicks. So transparent means that if you click on it, then it's like as if the click went through the image and it went through to the thing on the bottom. Okay, so now you trick the user. You have to get them to click on something, right? So maybe it's a CAPTCHA or whatever you can think of that a user would actually click on it. Like, select the image of a cat so you can go visit the website. And then you click the cat. But what you don't know is that when you're clicking the cat, there's this invisible iframe that's underneath. It's logged in to your Facebook account or whatever, and there's some element that's there from Facebook, like a like button, and now you're actually clicking that like button. Okay, and so there was a period where people are like, I went on my Facebook and there was all these like crazy posts. I must have been hacked, right? Someone must have guessed my password or something like that because I was posting ads for like random things. Chances are you weren't hacked. it wasn't that your password was stolen. It was that you fell to like some clickjacking attack where you went to some website and you clicked on things and it was doing stuff on your Facebook account. And Facebook is like, well, the user's clicking it, so it must be, it's not like just an automated URL that's getting sent to us. So it must be really the user that's doing it. But in reality, it was just an attack. Now, browsers, they've done a whole bunch of stuff, like basically, I don't know the state of the art, but I think that transparent clicks are no longer allowed, and there's other stuff that they do to like enforce that you can't put images over top of iframes. So anyways. Okay, so the lessons from the same origin policy are kind of the same as airports. It's hard to get the policies right. Developers don't understand the policies always, or they don't understand the ramifications. So like cross-site scripting, cross-site request forgeries, not always setting document to domain to like the top domain, or to your actual domain, the domain that you control. You know, these are things that developers don't think through the ramifications. They just do them, okay? In all of these cases, nothing we saw is bad. Like cross-site scripting in and of itself is not bad, okay? It's just that when you don't have the right mental model for what's going on, then it becomes bad. Cross-site requests aren't bad, right? But when you have the wrong mental model of how they work, then you could leave your website vulnerable to forgery attacks, okay? So it's really about getting developers and like the way developers think the web works and browsers implement these policies and what the actual policies are. You get them on the same page. There are ways to do things that are secure and like feature rich. You can have websites that, you know, are mashups of different websites and stuff like that. Anything you want to do on the web, you can do it. You can do it in a secure way, but you just have to really understand what the policies are. It's hard to analyze and ensure full protection of policies in general. Once you drop a policy, it's hard to change it. Okay, so we have seen some changes to policies over time. It's usually like announced 2 years in advance, and it's usually Google Chrome. They're sort of the most active on things. And so they'll say, you know, in 2 years, in 2024, you know, we're disabling this feature, right? And we don't care if that breaks your website. You have 2 years to figure it out, right? And then in 2 years, I don't know, 80% of the websites will have changed the way they work because of it. And then the other 20% will break. And then all the Chrome users will start emailing the website saying your website's broken. And then they'll say, oh, we should fix it because we don't want to exclude all our Chrome users. And then they'll fix it as well. So it's kind of like a process of bullying websites into changing, but it seems to work because Google's big enough to do that type of thing. It could be Microsoft, it could be Apple as well. But you know, I've seen historically that Google's usually the first to move on these types of things. Okay. But anyway, changes that you make probably won't be backwards compatible. And if you have some legacy websites that never update, then you're going to break them forever until they update. Some people want more complicated policies like, well, we have an iframe, so we should have like a policy about iframes, and then I can say what iframes are allowed to do and what they're not allowed to do, and I can customize it and things like that. And that's okay. So there is an approach of having more verbose policies that you can write into websites and resources and things like that. But complexity is usually, it kind of rubs up against security in a bad way because at the most basic level, just developers don't understand it. It's more complicated now, so they understand it even less. They're more likely to make mistakes. So even if the policy itself is fine, if people don't do the policy right, then it could even be worse than not having the policy at all. And then we've also seen a tendency of developers to just, you know, they just want to get the website working, right? And so if that means overriding cookie settings, overriding document origin settings, whatever, they'll do whatever it is. They'll give it the most permissive permissions possible so that it's the most compatible. And so that's how you program. You just program with maximum compatibility in mind, and then you don't really think about security as a result. Okay, so these are some of the challenges that you have when you set policies, trying to make sure that developers understand them and that they'll actually follow the policies. Okay, questions about any of this? All right, that's it. We'll see you all in 2 weeks. Any questions about the